In this lesson, we're going to climb some factor ladders. First, we're going to talk about the difference between prime and composite. Then we're going to answer the question, what is prime factorization? And then we're going to make some factor ladders. Let's talk about the difference between prime numbers and composite numbers. Prime numbers only have factors of 1 and itself. So for example, 7 only has the factors 1 and 7. 1 and 7 are the only numbers that divide into 7. Composite numbers have other factors besides 1 and itself. So for example, 8 has the factors 1 and 8, but it also has the factors of 2 and 4. And all of the numbers in this list have factors that are other than 1 in itself. The list of prime numbers here would be really good to write down because you're going to use that a lot in a future skill. What does it mean to prime factor something? What is prime factorization? Prime factorization means writing a number as a product of its prime factors. So 20 is 4 times 5, but 4 is not a prime number. So I can break 4 down into 2 more prime numbers. So 20 is 2 times 2 times 5, which is 2 to the second power times 5. And 30 is 2 times 2 times 3 times 3, which is 2 squared, 2 to the second power times 3 to the second power. And you'll notice that I really don't want to use x's to indicate multiplication. I'm using parentheses, and these numbers are all touching instead of using x's, because x's are variables in algebra. And so it's really important that we get away from using x to represent multiplication. So this is what prime factorization is. It's writing it as a product of primes. All right, so here we're going to find the prime factorization of 150. Now, you might have learned a different method of this. Sometimes people will know how to do trees, and they say, okay, what goes into 150? Well, I know 3 and 50, and then they branch that off until they get down to primes, 2 and 25. Does that look familiar to you? And then 5 and 5, yeah. Okay, that's fine, and it works, and if you're good with that, go for it. But we're going to use factor ladders. And the reason why I use factor ladders is because it's really clear to see what the prime numbers are. They're all lined up in a row together instead of kind of scattered all over the place. So you start by putting your number in an L bracket like this. And I'm going to write down the list of primes again for myself to have it handy up here. And I start with a prime number. And I say, does 2 go into 150? And by go into, I mean I take 150 divided by 2 and I see if it goes in nicely, evenly, where I get an integer answer and not a decimal. And it does. 2 goes in there 75 times. And then I do it again. Does 2 go into 75 again? And it doesn't. I get a decimal. So I'm done with the 2's. Then I go to 3. Does 3, so I just climb up the prime list here. Does 3 go into 75? Evenly. Can I divide 3 into 75? I can. 75 divided by 3 is 25. And then I do it again. Does 3 go into 25? So you want to keep repeating the same prime until it won't go in, it won't divide in evenly again. So 3 doesn't go into 25. Does 5 go into 25? It does! Oh, joy. How many times does it go in? 5 times. So your answer to your division goes right here. 150 divided by 2 is 75. 75 divided by 3 is 25. 25 divided by 5 is 5. And then 5 goes into 5. How many times? 1. And when you get down to 1, you're done! That's, I expected you to say. When you get down to 1, that's right, you're done. All right, and these are my prime factors all lined up in a row. So 150 is 2 times 3 times, I have 2 5s, so 5 to the second power. And that's how you do prime factorization with factor ladders.